Hello, and welcome to the conditional structure in Python. All right, now that you've written your first Python programs, you got comfortable with declaring variables, you got comfortable with casting variables, you got comfortable with operations, mathematical operations and operators and so on. It's time to move on and start looking at some of the other structures of programming. For the most part, our first week dealt with our sequential structure. Now we're going to start dealing with the more powerful structures of programming, conditional and iteration. All right. So this particular video, though, is going to talk about the conditional structure. And we'll have a little bit of review on the conditional structure. Then we'll talk about the relational operators in Python and maybe how they're a little bit different than maybe other languages you've already been exposed to. And then we'll write the conditional structure in Python. It's for the most part the same thing as you've done before, but there's some unique differences to it, but all in all very, very simple. And then finally, we'll talk about some compound conditions, basically ands and ors, and how you write those in Python. All right, with that, let's get started. Conditional structure is a programming feature that performs different processes based on whether a condition is true or false. If you look at these flow charts or example flow charts, like I said, what we've covered so far is sequential. We do one thing, after that's finished, we do the next thing, after that's finished, we do the next thing, and so on. All right? As we talked about in other classes, for the most part, the computer can only do one task at a time. It might be able to run multiple programs now with all the quad core processings and so on, but when it comes to programming, one thing is done at a time. And after that is completely finished, it goes on to the next task. That flow is how you need to make sure you understand your logic and write your logic. It needs to be first things first, top down. However, there's times within the flow a question needs to be asked, and based upon the answer to that question, you're going to do a task or you may do another task. That's really the power of programming. When we as programmers start asking all the exceptions, all the possible questions that could happen within a program. And that's what we do as programmers, and we make sure things work based upon that. With that said, a selection structure, okay, also aka conditional structure, basically asks the question. And if it's true, we do these set of tasks. If it's false, we will do these set of tasks. Once we figured all that out, we end the structure. That's what this little circle's for, and we continue on with our flow. That flow might go to another selection structure or conditional structure, or it might just sequentially keep flowing through the program, top down. The hope is you already understand all of this. This is a total review, and you're basically looking at this going, yeah, I got that, but that's great. I just want to make sure we're all saying the same thing as we move forward here. If we are comparing two things together in a conditional structure, we need to make sure we understand what the relational operators are to be able to do these tests. For the most part, you've been introduced to these once again in previous courses, but in Python, there is a little bit of difference. If we're going to compare A equals B, we need to basically do that using the equals sign, two equal signs back to back, not just one, two. Greater than equal to, less than equal to, those are all pretty similar to what you probably already know. The other one that might be a little bit different would be the not equal to. In previous courses, you may have seen a less than, greater than sign back to back representing not equal to. In this case, it's the exclamation point equals to, or the bang equals to, whatever you want to state there. So between the equal to and the not equal to, make sure you understand this. You'll get an error, don't worry about it. You'll see some, in some cases you may get an error, in some cases you might get some really odd outputs. But make sure if you're comparing A equals B in a conditional statement, like if A equals B, it's A equals B. Got it? That's the only big difference. You'll see that equals in a lot of languages. Again, Python is something that's derived by many different languages, C being one of them. And equals is what you do in C, C++, Java, and so on. All right, so those are it should be pretty similar, and you're going to get more used to equals than you probably would just using the equal sign in a conditional statement. All right, so how do we rate this? Well, it's not that hard. In this little set of code right here, if I have two variables, number 1 and number 2, and I set those to 33 and 200, if I compare those two variables, if number 2 is greater than number 1, I'm going to print number 2 is greater than number 1. This is how you write it. Note, there's no curly brackets. Note, there's no then. Okay, but in this case, what you'll do is you'll write your if statement, and then you end that if statement with a colon. You see that there? A colon must be there. If you're using a proper editor, it'll make sure it's there, or it'll give you an error, or give you the red squiggly lines, or whatever you're looking for. So the colon must be there. And then we basically put the statement, the true statement, sitting right here. In this particular example, the false statement is basically assumed that we're not going to do anything. There is no else here in this case. We'll talk about that here in a minute. So note the colon. Also note the one thing that Python really wants you to do, indentation. Since there is no then, there is no curly brackets, Python only recognizes the statements that are indented as the task that you want to do based upon if the condition is true or false. So we must indent all those pieces. I must indent every line that's true or false. Does that make sense? Let's talk about that a little bit more. So Python relies on indentation using white space to define scope of the code. Other programming languages often use, like I mentioned before, curly brackets or the word then for this purpose. So in this case here, if we write this in Python, if int number 2 is greater than int number 1 and we don't indent it, you will get an error. That's wrong. It will tell you got an error right off the bat, okay? It can be either syntax error or a runtime error, but you'll get that error. What's correct is you indent, okay, the things that you want to actually put in your conditional statements. If you have a proper editor, it'll probably help you do it. But for the most part, make sure those statements are indented in Python to make it work. Pretty simple. The else statement. It's also very simple. Notice what we're doing here. In this case now, I took my past program and I said if number 2 is greater than number 1, I'm going to print number 2 is greater than number 1, else number 1 should be greater than number 2. So in this case here, I have my else, I indent my print, I indent my print, I have my else with the colon. Okay? So that's how you do that. There is no end if or anything in this particular language, okay? And there is no ending curly bracket in this language. It's basically written like this. As soon as the next line is not indented, it will not be part of the structure. So if I wrote after this, I don't know, something new after it, and we'll maybe show that in an example later on, it's not part of the conditional structure, only those things that are indented. So if my next line says, I don't know, print I'm finished, it would not, if it's not indented, it would not be part of that else. Pretty cool, pretty interesting. Also opportunities for mistakes, so make sure you know what you're doing. And when I say mistakes, maybe you wanted that next line to be part of the else piece of it. If you don't indent it, it will not be. And that line then will run for if it's true or false, basically after the structure. Does that make sense? So you could end up with some logic errors if you don't pay attention to what you're doing in this case. All right. The elif is the else if. I know a lot of you people are familiar with that. So in this case here, if we're sitting back and we're saying, okay, if the number 2 is greater than number 1, we got this. Else if int number equals, here's that equals sign, number 1, then we know they're equal to each other. So once again, elif, notice the colon at the end of that one. So we're basically, it's like a nested if in a case, right? So we got if int number 2 is greater than int number 1, we do it this way. Else if, that's what the elif is for, we're going to then ask another conditional statement. All right? So if you're asking multiple questions, nesting the if and so on, elif actually works pretty well. If we put all this together and we kind of look at it this way, and we kind of finish our program by comparing these two numbers. If 2 is greater than 1, then we would state so. Elif, if int number is greater than equals to int number 1, it's equal. If it's not greater than, if it's not equal to, I'll put an else right here, and we know that number 1 is greater than number 2. Does that logic make sense to everybody? I hope it does. So this is basically the structure. Once again, note the indentations. Note the colons at the end of every if statement, elif statement, and else statement. You get that down? That's how you write a conditional statement. All right? Compound conditions. The and keyword is a logical operator and is used to combine conditional statements. So in this case here, if int number 1 is greater than number 2 and number 3 is greater than number 1, both conditions are true. So basically what we're saying is to get to this print statement right here that both conditions are true, both of these need to be true. Another way of writing this is the or statement. Yeah, we could sit back and say if number 1 is greater than number 2 or number 3 is greater than number 1, at least one of these conditions must be true to actually get there. I don't write a ton of compound statements. Sometimes they get confusing and sometimes they're hard to maintain and hard to test. But there's times you must write a compound statement. Like I said, I usually shy away from them sometimes, just from the mere fact of maintenance and readability. But if I need to do it, this is how you do it. Not that big a deal. All right. So the next video will go in and show you an example of how to write this, actually write a program with some conditional statements already in it and play around with that. All right. But hopefully you got an idea of how to write this. Once again, I provided you the resources that actually review all of this also. I recommend you go read those resources to make sure you completely understand how to write a conditional statement in Python.